So moving on to video number 2 now, where I'm discussing Russell Barkley's criticism of the whole idea that ADHD, and we can also say any other neurodevelopmental condition, by the way, substitute autism for that, substitute any other condition, that these conditions are somehow were ever an advantage. Russell Barkley has thoroughly critiqued this, and it's very well evidenced, his critique. So let's get on now to the evidence. Okay, so we talked about the conveyor belt metaphor of genetically produced psychopathology, and that conveyor belt metaphor is the product of Keller 2008 of their research, Current Directions in Psychological Science. It's important to treat all evolutionary psychology with a very heavy grain of salt. The fact that most behavioural traits are polygenetic, and it's hard to isolate the impact of any one gene on adaptiveness anyway, a combination of genes might lead to a constellation of maladaptive traits, but there isn't equivalent to all those gene variants or traits being maladaptive. Because you've got to remember that conditions like ADHD are syndromic. It's not like one gene or one trait, it's a collection of traits occurring together at to a very extreme extent. When you get something to a very extreme extent, that then usually, there are exceptions, but usually becomes pathological. It's over and above what is functional, what is adaptive. It's not good to be at an extreme. So it's not the case that these genes and these traits in isolation necessarily are maladaptive. They're perfectly human traits, are perfectly human, it's perfectly human. And these traits are widely distributed in the general population, not causing any problems. But when they occur together and at a great enough extent and intensity, then it becomes a disorder. And that is not adaptive, and never has been adaptive. Citing single genes and their potential adaptive value does not rule out the point that multiple gene variants in combination can prove pathological. So as I said, he talks about conveyor belt. So in a conveyor belt theory, in the first generation of people, enough new mutations occur to create ADHD. That arises in ADHD-related genes. Then, as you move along the conveyor belt to the second generation, some cases die before reproducing, so the mutated genes disappear. Those surviving are passed on to about 50% of offspring. So that's now the third generation. And then more cases die before reproducing. And then you get to the fourth generation, where, say, few or no ADHD offspring survive to reproduce. Even more cases die before reproducing. Meaning, again, some mutated genes will then disappear. So now none of the original mutated genes exist any longer, but constant new mutations are happening. So even though these genes have been weeded out by selective pressure, new mutations are occurring all the time to replace the genes that have been weeded out, resulting in a steady weight of ADHD, an equilibrium. So if the mutation weight in ADHD-related genes matches the decreasing survival weights for those genes across generations, then a stable rate of the disorder can exist in a population, around 5 to 8% in this case. So further evidence against the adaptationist views now. First of all, there's a higher risk for injury and death. and a higher risk for multiple medical disorders in people with ADHD. Also, a 2020 study by Calcutta et al., study in Nature Scientific Reports, has compared ADHD gene variants in samples of humans in modern, ancient and archaic populations going back to the Neanderthals. They found substantial evidence that natural selection has been acting against these genetic variants throughout evolution. A genomic analysis of a natural history of ADHD using Neanderthal and ancient Homo sapiens samples, Nature.com Scientific Reports, that's Calcutta. And they took advantage of the largest meta-analysis for the disorder. So that's quite a lot of evidence there. They've gone through the whole genomic database. Okay, and they found evidence that these genes have been weeded out by evolution. So that says something, doesn't it? This is real scientific evidence, not hearsay, because that article I went through from The Guardian was just might have been, maybes, hypothetical conjecture based on laboratory study, which of course is not the same thing as in the wild study, and not based on any genetic evidence at all. Well, here we have conclusive genetic evidence that shows that these genes have been weeded out by evolution from the earliest days. That's science. When you have enough evidence like that, you know, you can't really argue against it, because evidence is evidence. Now, if there was evidence that came to light that showed that actually maybe ADHD had been a genetic advantage, let's say, you know, new evidence might come to light, then obviously we change and we say, okay, because we go in line with the evidence. But currently, the evidence is that ADHD is not an evolutionary advantage and is actually the opposite. These genes have been weeded out by evolution. But as Barkley says, adopting a false belief because it makes one feel better does not help with addressing any existing problems, but papers them over with a delusion. So that's the main evidence against the adaptationist view. I mean, you've got to also remember, of course, that sometimes a trait is just a glitch and it sticks around because it's not quite enough of a problem to get to get selected against. I mean, here, as I've just said, there is actual evidence that these genes have been selected against. But even if there wasn't such evidence, evolution, it's not always the case that traits hang around because they're necessarily advantageous. Sometimes traits just hang around because they're not so severe that enough people don't go on to reproduce. And when you're thinking about something like ADHD or autism, these genes are really widely dispersed within a general population. Many people carry these genes without having the disorder in the first place. They will, of course, go on to reproduce quite happily and pass on the genes. And aside from that, lots of people with these disorders don't have them severe enough not to be able to reproduce, particularly with ADHD, of course, because ADHD doesn't affect, like, ability to reproduce or have partners. Quite a lot of people with ADHD are actually quite, particularly those who are impulsive and hyperactive, are often quite, sort of in a way, quite promiscuous and will often or can be, I don't want to form a stereotype, that's probably the one way of putting it. Of course, most people with ADHD, what I'm trying to say is that maybe there's a tendency for some people with ADHD to be maybe a bit promiscuous in the sense of seeking out partners and stuff because of that kind of need for a dopamine hit. But basically, ADHD doesn't affect someone's ability to reproduce, and so these genes are going to get passed on, because it's not like a disorder where most people with the disorder end up dying before reproductive age, although, as Barkley has made clear, there is quite a high childhood mortality rate with ADHD because of sort of risky impulsive behaviours. But nevertheless, most people with ADHD do reach adulthood, and a large percentage of those will reproduce. So obviously these genes are going to get passed down. That doesn't mean that these genes are adaptive in any way. And even with autism, although autism is a social disorder, so it might be expected that maybe many autistic people find it a lot harder to find relationships. You might find that on average, maybe autistic people are less likely to have kids. But nevertheless, autism is a wide spectrum, inverted commas, and many autistic people do have children. And likewise, lots of people carry autistic traits. You might just have subclinical traits, or or carry the genes without having autism, and will likewise go on to reproduce. Doesn't mean that these traits are adaptive. It just means that it's a polygenetic disorder where the genes are widely dispersed and they're very easily passed on. It's not like disorders where most of the people with it die off before reproductive age. In fact, and also, like as Barkley said in a conveyor belt theory, also factor in a very high mutation rate. The autistic risk genes, the ADHD risk genes, occur in a very unstable part of the human genome. It's a comparatively recent part of the genome. It's very, very unstable. It's still evolving, so you're going to expect to see a high rate of mutations there. Even all of the common genetic variants, all of those common genetic variants began as a mutation. It's just that they're now widely dispersed and common. But they all began as a mutation that has then ended up being inherited. And then of course you have the so-called de novo mutations, which are a lot rarer all genetic variation began as a de novo mutation. So and then some of those end up becoming widely dispersed. We talk about them as common genetic variants because they've become common, but they all began as mutations, and new mutations are occurring all the time. Okay, so let me know what you think. I will come back to this, and I will go on and have a look at your comments, and also I want to also go over another Russell Barkley video at some point where he critiques the whole idea that people with ADHD are more creative, and also critiques the whole idea that people with ADHD have high IQs, critiques the whole idea that people with ADHD are more likely to be entrepreneurs. So very good critiques on there, and also he is very scathing about the whole neurodiversity idea that ADHD is not a disorder. So I'll be getting on to those critiques soon. But yeah, let me know what you think, and thank you for watching.